Okay, so the idea of adapting things to work together, you can imagine, since this is such a fundamental operation of code reuse, right? You've got something that kind of does what you want, but doesn't do it exactly the way that you would want it. It shouldn't surprise you that there's a number of patterns that in some way or another end up dealing with this. And we've just seen the first couple. Here's another one that will help you solve the following problem. When you're testing, writing, designing your code, a thing that makes your code more robust and testable is having invariance, right? Having only one way that certain things are done, because you can rely on certain conditions always being true. But there are some very common cases where the requirements of the application seem to work against you in trying to do this. Here's an example. Imagine that you have some code paths in your application that behave differently depending on, let's say, whether the customer is logged in. Or if the customer is logged in, then they behave differently depending on whether they're a premium customer or a regular customer. One possibility, the naive thing to do, is you could put case statements all over the place so that whenever you're dealing with one of these methods, you can actually change the behavior depending on, if nobody's logged in, do this. Otherwise, if someone's logged in, then check if they're a premium customer or not. But here's another thing you can do. You can essentially create special objects on which those methods always return something usable. So for example, and I'll show an implementation in a moment of how you would do null customer. But the idea is I can create basically a fake customer on which logged in always returns false, is VIP or is premium always returns false. If you try to ask what the customer's name is, you'll get some semblance of something legal. But the idea is that I can use this, and now my code paths don't have to depend on whether somebody's logged in, right? What happens is by default, I will assign, let's say I have a session variable for who's logged in. Initially, I'll just assign it to be the null customer. So I can still do all of the things. I can perform all of the checks on it that I would perform if it was a regular customer, but the checks will always return values that are the right thing for nobody being logged in. Right? You can see that that's a lot more elegant than having completely separate code paths for being logged in or not. What does this look like in terms of my application? If my customers are the theaters that use this app, some of them use MailChimp, some use Constant Contact, some of them don't have any external marketing service that they use. So I could either go through all of my code and find every place where I'm doing an operation related to email lists and condition it on whether they have a relationship with an email provider, or I can create a subclass, a fake email list, that just does nothing. If I call customer opt-in on the fake email list, it just does nothing. If I say add the customer to this list, it does nothing. But it does nothing in a safe manner, right? In fact, I could even do nothing and add an error message displayed to the user saying, thanks for trying to do this, but hey, you don't have a relationship with any email list service. So in every way, it can stand in as a regular object type, but it has behaviors that correspond to what would otherwise be a whole separate code path. That's how null object helps clean these things up. And a particularly nice way of doing the null object pattern is to use a singleton, which is yet another pattern. It's a way of ensuring that there's only one of something, that you have one instance of something that anyone can access. So in the example I just gave, what you'd really like is for that special customer that's fake to be an instance of the customer in every respect, but on that particular instance, the methods are essentially overridden to always return something corresponding not logged in. And confusingly, the method by which Ruby supports this very nicely is called the singleton class. Unfortunately, the singleton classes is not related to the singleton pattern. Sorry, that's the way it is. But the singleton object is basically, what you do is you create an instance of the class, and you make that instance special, and then you arrange to return it as the value of a null object. Here's an example of how you might do it, since these things are invariably easier to see than they are to explain. So in this example, here's what my regular customer class would have: methods for name, it would have a getter and a setter. But here's what happens if you try to get, suppose we want to implement a singleton, a single null customer that we could use as the stand-in, let's say for when nobody's really logged in. I have a class variable that I'm going to create a new instance of the customer, store it in the class variable, and then, this is a weird Ruby incantation, but what it's basically doing is say, make this thing essentially be its own class. It's a class that only has a single instance, and I'm it, right? So and for this instance, which is in if you ask it, are you a customer, it will say yes, right? It is in every way an instance of customer, but we can now, because it is its own little class, we can override instance methods on it. It's almost like we made a subclass, and we're overriding instance methods in the subclass, except that it's not a subclass. It's really an instance of customer in every other respect. It quacks just like a customer, but now we can do these overrides to use this thing as a null object. So this is, there are Other languages provide similar ways to do this. This is probably the most elegant implementation of it that I've seen. So now, whenever we call self null customer, if this instance has never been created, it'll get created and stashed in a class variable. And if it has been created, then we just have to return it. Right? So this is a really nice, elegant implementation of doing the null object pattern. It's not the only thing you can do with singleton classes, but it's a particularly compelling one. And by the way, we also made it immutable, right? And when you're trying to assign something to the null customer, you can just have the setter ignore the assignment, or you can have it raise an error. So you can override basically every behavior. A related version of all this, again, in the fitting things together that almost but don't quite fit together the way you want, is a proxy object. And the problem this solves is you have a scenario where you need something that implements a set of known methods but might behave differently depending on the situation. For an example would be that if you have a remote service, email is a good example of this, right? If you're connected to the internet and you hit send on an email, the thing that should happen is it gets sent. But if you're disconnected from the internet, arguably the thing that should happen is that it gets queued for sending later. And it would be nice if the client doesn't have to worry about the difference between those two. So basically, in one case, you're going to have an object whose send method will send the email out. But when you're disconnected, you want to temporarily replace it with an object that will still have a send method that will behave just like a send method, except transparently it'll do something different, like queuing the email until you reconnect later. Rails, again, has an example of this pattern in the wild. And surprisingly, it's in the associations. So if you remember, when you do an association in Rails, you get back these things that behave just like collections. And I've always said, because of the lazy evaluation, they're not really collections. The query hasn't actually happened yet. This is a classic example of a proxy object, right? So remember when we said movie.reviews, what kind of a thing is reviews? Well, initially, it's not anything, because the query doesn't happen until you try to consume it. And then when you try to consume it, it behaves like an enumerable collection. That's a proxy object for an enumerable collection, right? Because you can behave as if this was, as if reviews was in every sense an enumerable, and you can just write your code that way. But in fact, what it's doing is something more complicated. It's actually building up query state up until the moment the query is done. And then once the query comes back, it behaves like an iterator over that collection, right? So that's a classic example of a proxy object. Here's an example you've also seen, and you get to decide which one this is. When you use fake web, or when we use fake web to stub external requests, like we did in the example for the TMDB gem, which design pattern is arguably the best description of what this is an example of? Is it most like using null object, most like creating a proxy object, most like creating an adapter, or most like creating a facade?